Hello everyone. Good evening. Is my voice is clear and the screen is visible to everyone?
Yes, sir.
Okay. Great. Today we are going to have a discussion on the very special topic under the analysis, which is the chromatography. So basically, chromatography is such an important topic while coming to the pharmaceutical analysis that every year in GPAT and NIPER and whatever the other competitive exams you attempt of the pharmacy, without chromatography, there is no question paper is constructed. So that's what importance has the chromatography has in while coming to the in terms of examination and also its application in the pharmaceutical industry, food industry, etc. So first, let us have a deep basics clears regarding the chromatography because some of the times, some of the years like in 2022 and 2023 and 2021, the basics questions were asked from the chromatography techniques. So basically, chromatography is nothing but a separation technique. So it is a physical separation technique where basically the two main separation techniques or the more than two are there. So basing upon the separation technique, there are different types of chromatography. So it can be a adsorption chromatography. In adsorption chromatography, the separation is nothing but based upon the adsorption phenomena. So as we guys know that there is a two phenomena like adsorption is the surface phenomena where the one particle get adsorbed on the surface of the another particle. So absorption is the bulk phenomena. While when we see in the absorption, the molecule enters into this molecule, but while the adsorption it remains on the surface. So basically, in chromatography, we try to separate the components. For example, you have a mixture, for example, it consists of five components. So basically, by performing chromatography, you try to separate them into individual components. One, it's two, it's like this. So the chromatography can be analytical and preparative. So basically, for the analytical chromatography, main aims to quantify the analyte present in the sample. So it is basically quantification purpose. While coming to the preparative chromatography, it is only for the qual- qualitative means which means that you only main motto is to only identify which type of analytes are present in the sample. So basically it is more related to the identification. So during the teaching, wherever I say the term preparative, it means the qualitative, and if I mention the term analytical, then it refers to quantitative. So basically the chromatography is the technique. It is the technique and the graph which we get from the by analyzing by chromatography is known as chromatogram. So chromatogram is the visual output of the chromatograph. So basically the visual output where we can able to interpret our analysis, where we can able to detect that which of the analyte were present in our sample. This whole visual inspection comes in the form of graph in a computer. So that graph is known as chromatogram. So while I mentioned that chromatograph is the equipment that enables the sophisticated separation. So there are different types of separation techniques, so which we have different separation principles also. So basically, when we talk about the adsorption chromatography, so guys, do you know that first of all the chromatography term was given by and the first chromatography was done by which scientist?
Michael T. Sweat.
Great, great. So Michael Tischer, so basically what he has done. So basically he has used a column. So basically he has taken a column. In the column, he has packed with the calcium carbonate, CaCO3. It has he has packed with the calcium carbonate, and he has a taken of sample. The sample was generally the green plant pigments of the green plant, and he has used a solvent which is a petroleum. Basically, you have used the hydrocarbon mobile phase. So the solvent, which is basically mobile phase here. Then, by basing on the principle of the adsorption, he was able to separate the different plant pigments. into different colors. So that's why he gave the name chromatography. Chroma means nothing but color. So basically, here the whole during the whole studying of the chromatography, you will come across the two terms. So you'll come across the two terms. So which is first one is the stationary phase, which is written in the short form as SP, and another one is mobile phase, which is written as MP. So basically, stationary phase is something which is fixed into the column. It is generally static in nature and it is immobile. So basically, we take a column. For example, I have taken a column. So in that column, I generally pack my column whole with the stationary phase. And then I dissolve my sample in the mobile phase, and the phase plus sample is passed through the column. So based upon the whatever the principle, the sample gets separated and the mobile and comes out along with the mobile phase and detected by the detector. So stationary phase are rigid, static in nature. Mobile phase, as the name mobile, mobile is nothing but mobility, movement from one side, one point to another point. So mobile phase are something like solvents which move in throughout the column. So basically, the separation can be based upon the different principles. So there are two terminologies also you will get encounter. First one is the LU8 and LU8. So LU8 is something, for example, you have added a mixture of sample which consists of four samples, four analytes, and you have passed first, you have dissolved your sample in a specific solvent or a specific organic phase. So basically, when you dissolve and we add to the column which is known as LUN, and after separation you get different fractions of the mobile phase from the column. So basically you eluate your column. By elution you get the different fractions of the eluate. So each eluate consists of the each analyte from the mixture of sample. So I think so these two terminologies have been clear to you guys. So now when we talk about the basic principles of the chromatography, there can be different separation principles. It can be adsorption, it can be partition, it can be. So first one, let us have a view on the adsorption. So basically, in adsorption chromatography, we coat our sample, our stationary phase is solid in nature, and we coat it on a column. So basically, and then we pass the mobile phase through the column. The mobile phase along with the sample is passed through the column. The different components present in the sample would have a different affinity with the stationary phase. So for example, one sample will adsorb here. So let us extend this. One sample will adsorb here. One would be adsorbed here. And we pass the mobile phase. And basically the absorption is occur by very weak molecular forces, weak intermolecular forces like van der Waals forces, ionic bonding, hydrogen bonding, etc. Then, after passing the mobile phase, by which we can able to separate these components based upon their adsorption affinity. So, the compound which have the less adsorption affinity will come from the column earlier or late, guys. The sample component which has the weaker adsorption affinity will eluted from the column fast or late. Come on, guys, answer. Fast. Great, Vivek. Great. So basically, the compound which great, guys, great. So basically, the component which has the less adsorption affinity will be retained less in the column and will get eluted out fast from the column. So this is the basically the whole scenario of the adsorption chromatography. So while coming to the partition chromatography, in partition chromatography, the stationary phase and the mobile phase both are liquid in nature but are invisible with each other. The stationary phase and the mobile phase are liquid in nature. So basically, the stationary phase is coated on the solid. So we take a solid beads which can be made up of silica or which may be made up of glass beads. on the surface of these beads, we coat the stationary phase. So we basically coat the stationary phase layer by layer, and these many particles then packed into the column. And then whenever we try to pass the uh, mobile phase, the molecule get partitioned between the stationary phase, which is liquid, and the mobile phase. So those components which are having more solubility in the mobile phase will be eluted out first. Then the components which are having the more affinity or more solubility or more interaction with the stationary phase liquid will be eluted out late. So basically, this happens in the partition chromatography. And the partition chromatography is the principle in mainly in the HPLC, which is known as high pressure liquid chromatography or high performance liquid chromatography. And another one is the size exclusion chromatography. So basically, in size exclusion chromatography, the molecules are separated based upon their size and the molecular weight. So basically, here the whole column is packed with a gel, basically packed with the very porous particles. The stationary phase is porous in nature, so which specifically has a specific diameter opening. So whatever the sample analytes which are added, if their size is less than the diameter, then they will enter into the pores of the stationary phase and will be eluted out late. And those which are having the larger size when compared to the pore size of the stationary phase will be eluted out first. So this is the basically whole principle of the size exclusion chromatography. And another chromatography is the ion exchange chromatography. In ion exchange chromatography, based upon the charge, there is a charge. The cations and anions are exchanged between the uh, column and the sample by which the sample separation occurs. So basically, this is the whole broad major principles of the chromatography, and there is also another chromatography which is affinity chromatography. So affinity chromatography, which mainly is a very selective chromatography, and it is mainly based upon the antigen antibody reaction, protein antibody reaction, etc. So as I mentioned that LU8 is nothing but the mobile phase leaving the column, and LU8 is the solvent with that will carry the analyte. So heliotropic series is the list of solvents ranked according to the elution power. So based upon the solvents, dielectric constant and their polarity, there is a heliotropic series has been prepared. So while coming to the development techniques, so basically, do you guys know the difference between the normal phase chromatography and the reverse phase chromatography? I think that everyone must know about the normal phase and reverse phase. Come on, guys, say me what is normal phase chromatography? Answer me. What is normal phase chromatography?
Stationary phase is polar and mobile phase is non-polar.
Good, 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 good. So while coming to the reverse phase, same, the mobile phase is polar and stationary phase is non-polar. So based upon the polarity also, and the most widely used which one, guys? In normal industries uses mostly normal phase or the reverse phase? Reverse phase. Good, great, Deepika, great. So basically, most widely used is the reverse phase chromatography because the polar solvents are cheaper in nature and are easily available, and they are somewhat environmentally friendly. So basically, there are different types of analysis can be done. So where I mentioned that elution is the elution analysis, as I mentioned, uh, front-end analysis. In front-end analysis, a large volume of sample mixture is continuously passed through the column. Most we- most weakly retained component of the mixture emerges first. So as I mentioned that those components which are having the weaker interaction with the stationary phase would be eluted out first. Next one is the displacement analysis. In displacement analysis, the sample mixture basically dissolved in a large volume of solvent applied to the top of the column, and the mobile phase containing displacing agent is passed through the column. So basically, it is all about the displacement reaction from the one place where the one component getting displaced by the another component. Next, elution analysis. So which is known as isocratic and gradient. So isocratic. So during whole chromatography technique, the polarity of the mobile phase remains same. The polarity do not changes. While the gradient elution, the polarity changes during the chromatography. So this is also basically known as solvent programming. So basically in isocratic elution, we do not change the composition of the solvent. For example, I have started with the 50% methanol and 50% acetonitrile. So during whole chromatography, I will maintain this ratio only. But while coming to the gradient elution, I will change. For example, first 1 hour I am starting with 45, 50. Next hour I'm taking 55, 60. So like this, I'm changing the concentration of the solvents so that I can change its polarity. So guys, say me by which elution the efficient separation of the components can occur. Come on, guys, answer. Is the gradient elution give the efficient separation or the isocratic? Come on, guys. Is the gradient elution give the perfect or the isocratic? So basically, good guys, gradient, gradient. So gradient, by changing the polarity, we can able to extract the minor amount of components present in our sample also. So basically, as I mentioned, the chromatography involves a sample being dissolved in a mobile phase. Basically, whatever we sample which is administered is dissolved in mobile phase, and the mobile phase is then forced through the immobile immiscible, which is known as stationary phase. So basically, here you have to remember one point, that stationary phase and the mobile phase do not have interaction with each other. They both are immiscible with each other. This must be remembered to you guys. The phases are chosen such that the components of the sample have the different solubilities in the each phase. As I mentioned that the component which is having more solubility in the mobile phase will be eluted out first. Then the components which are having more solubility in stationary phase will be retained in the column and will be eluted out late. So this is the basically. So basically distribution of analytes between the phases. So distribution of analyte between the phases can be often described analyzed in between. So basically the analyte get distributed between the mobile phase and the stationary phase. So as I mentioned that until the equilibrium is achieved, and this is known as partition coefficient. As we also know that in log P determination, in log P determination, we uses the two solvents. Which two solvents are used in the determination of log P, guys? Which two solvents are used? Water and octanol. Great, great. And octanol is used. Great, great, Vivek, in this system. So basically, this is nothing but our component get distributed between the organic and the polar phase. So this is also known. This is the whole principle of the partition. So basically, in HPLC, gas chromatography, and another chromatography, there is a nothing but the retention time. So retention time signifies the amount of time that a analyte presence in the column. So if a analyte having a longer retention time, then it is residence in the column for the longer period of time, and it will be eluted out first. So basically, the graph we can see that this is the time versus the where concentration, where the intensity. So the compounds which are having the larger retention will show the peak in the later time, which means that these are having more affinity towards the stationary phase and they are retained in the column for the longer period of time. So this retention time is different for the different components. And the time taken for the mobile phase to pass through the column is known as Tm. So basically, there is also a term which is known as retention factor. So these are the very, very important terms which we have to remember, guys. Retention factor, which is used to determine the migration rate of the analyte on a column. So you can also find it called as a capacity factor, also known as. So basically, the retention factor is equal to uh, TR minus TM by TM. So this is the formula for the retention factor, where as I mentioned earlier, the TR and the TM are the retention time and the retention time for the mobile phase. So basically, when an analyte retention factor is less than 1, so its retention factor is less than 1, it's in each. it indicates that its elution is so fast that its determination of retention time is very difficult. So basically, if something, if some of there are some of the analytes which basically have very low affinity towards stationary phase, by which their retention time sometimes get equalized to the TM, which is mobile phase time. And the high retention factors basically greater than 20 mean that elution takes very long time. So basically, the retention time ideally should be between 1 to 5. So here you have to give remember guys retention factor, which is nothing but the Ka. It should be between 1 to 5. It should be not very less. It should be not very high. And there is another term which is known as selectivity factor, which is denoted by the alpha. So basically, it compares the retention factor of the two analytes. So basically, for example, my sample consists of the four analytes A, B, and C and D. So if I compare the retention factor of the A and D or B and C, then it is known as selectivity factor. So selectivity factor is always greater than 1. This also you have to remember, guys. The selectivity factor is always greater than 1. It is never less than 1. So next, another important is the peak which we get. The peak in the chromatography which we get should be sharp in nature, should have a sufficient intensity, and should not be broad in nature. So because sometimes the broad peaks can indicates the poor column efficiency, and the column maintenance is also very important, guys, because the HPLC columns and the gas chromatography columns are very costly. They each column can cost up to 5 to 10 lakhs. So there must be a proper maintenance of the column. The column should not be damaged by the harsh solvent or the impurities from the mobile phase or from the sample. So basically, in HPLC column also, before the HPLC column, there is a special column which is placed. Do you guys know that name of that column? In before the HPLC column, a special column is always placed.
Box column.
Guard column, great. So basically, the guard column protects the main column. So guard column consists of the same stationary phase which is coated on the main column, but significant of the larger size. And the size of the guard column is generally smaller when compared to the main column. So for example, if our sample consists of any impurities, then those all impurities will get entrapped in the guard column, and only the pure sample would be passed into the HPLC column. So another most important thing in the HPLC is does the solvents which are used for the HPLC should be degassed or they are standard normally? Answer, guys. The solvents which are used in the mobile phase, which are used in the HPLC, are degassed or they are they are degassed. So basically, why they are degassed? Why the mobile phase of the HPLC are degassed? Do you guys know the rationale behind the degassing? What is the main purpose of the degassing of the mobile phase used for the HPLC bubbling? Yeah. So because the mobile phase flow with such a high pressure to the HPLC column, as the name signifies, the HPLC is also known as high pressure liquid chromatography. So during the high pressure, if there is any air entrapment in the mobile phase, it may can lead to formation of the bubbles within the column, which can significantly lead to increase in the pressure within the column, and it can damage the column. So that's why whatever the mobile phase are used for the HPLC are filtered out, are filtered properly, are properly degassed, and the special grade solvents are used which are free from impurities. So another terminology which very important for the column to determine the column efficiency and the chromatography is the theoretical plate model. So basically, what is the theoretical plate? So plate model suppose that the chromatographic column contains a large number of separated layers called as theoretical plates. So each theoretical plate indicates each analyte. So basically, separate equilibrations of the samples between the stationary mobile phase in these plates, and the analyte moves down the column by transfer of the equilibrate mobile phase to the one plate to the next. So basically, whenever let us whenever as I mentioned that there is always equilibrium between the mobile phase and the stationary phase. So basically, at a particular time, the analyte get equilibrium between the mobile phase and stationary phase. So it forms one plate, which is known as theoretical plate. Theoretical plate indicates the equilibration of this analyte between the stationary and mobile phase. So the column which is having more theoretical plates is more efficient or it is less efficient. The column which is having a column has a more theoretical plates, then it is more efficient or less efficient.
More efficient.
Great. So basically, a column which is having the more theoretical plates, it regarded as the more efficient because it can able to separate a wide range of compounds. And there is a another important term which is known as HETP, height equivalent of the theoretical plates. HETP, which is equal to L, which is nothing but length of the column determined by number of theoretical plates. So as the number of theoretical plates increases, the HETP, the width or the height of the theoretical plates decreases. So here it is come guys. HETP is equal to L by N. So basically, it is important to remember that plates do not really exist. So it is basically whole a theoretical phenomena. It is not practically observed. They are basically the imagination that help to understand the process that work in a column, and also serve to measure the efficiency as I mentioned earlier, either by stating the number of theoretical plates and more the plates is the better the column, or stating the height. So height should be smaller and the number of plates should be larger. And this is another important formula which is used to calculate the number of plates. And I think that in GPAT 2023 second phase, they have asked us to calculate the number of theoretical plates. So basically this formula you have to remember guys, here it comes. So another most important equation for the both HPLC and the gas chromatography is the, which is basically Van Diemert equation. Van Diemert equation. So this is very important, guys, which comes under the red theory of the chromatography, which states that the more realistic description of the process at work inside of column takes account in the time taken for the solute to equilibrate between the stationary and mobile phase. As I mentioned, that every analyte get equilibrates between the stationary phase and the mobile phase. So resulting band shape of the chromatographic peak is therefore affected by the rate of elution. So some of the components are lately eluted, some of the components are eluted by which the band shape, the peak shape get affected. So basically, the Van Diemert equation states that HETP is equal to A plus B by U plus CU, where U is the common term which indicates the velocity of the mobile phase, and A, B, C are the different factors. The A indicates the eddy diffusion or multi-path effect. So what it states that uh, the mobile phase moves through the column which is packed with the stationary phase. Solute molecules will always take the different parts to the stationary phase at the random. This will cause the broadening of the solute band because different path lengths have different lengths. So basically, this is a column and it is packed with the stationary phase. So different solute molecules will follow the different path of the movement through the stationary phase. And due to the stationary phase, different paths followed. For example, this is one molecule, this is one molecule. This molecule follows this pathway. Another molecule is there, it follows this pathway. So due to the different pathways, and as we also know that molecules always try to travel in the shortest possible distance. So due to these different pathways formed by the molecules, it leads to peak broadening. The peak bed broads. It leads to peak broadening. So it is known as the eddy diffusion. So another one is the nothing but the long. So basically the eddy diffusion is considered as zero while coming to the gas chromatography. So for the gas chromatography, we remove the A, the equation removes BU by CU. Next one is the longitudinal diffusion. So longitudinal diffusion states that the concentration of analyte is less at the edges of the band than at the center. So basically, due to the high velocity of the mobile phase in the center, the concentration of the analyte in the corner is less when compared to the center has the more analyte. Analyte diffuse out from the center to the edge. This causes the band bonding. If the velocity of the mobile phase is high, then the analyte spends less time on the column, which decreases the efficiency of the longitudinal accretion. So basically, what happens is whenever in the center, the concentration of the analyte is more when compared to the edges. Due to the difference in the concentration at the center and the edges in the column, the analyte try to shift towards the edges. By shifting towards the edges, it leads to band broadening. The what are the peak which we get broad. So in order to avoid this diffusion, we increases the velocity of the mobile phase. By increasing the velocity of the mobile phase, there is not a sufficient time for an analyte to get transfer into the edge by which they get eluted out from the column. So for basically for the HPLC, we cancel the B value and we remind it. So basically we get the different. So B value is neglected in case of the HPLC, which indicates A plus CU. As I mentioned, for the gas chromatography, we get BU plus CU, and for the HPLC, we indicate A plus CU. Next, the third term C, where C is nothing but the resistance to mass transfer. So basically, which indicates that the analyte takes a certain amount of time to equilibrate between the stationary and mobile phase. If the velocity of mobile phase is high, then the analyte has a strong affinity for the mobile stationary phase. Then the analyte in the mobile phase will move ahead of the analyte in the stationary phase, and the band of the analyte is broadened. Higher velocity of the mobile phase was the broadening process. So basically, it is nothing but the mass transfer. So we we have to not maintain too high mobile phase velocity or too low mobile phase velocity. There must be a balance between the mobile phase velocity. So this is basically the plot how it typically look like. In x-axis, it is the mobile phase viscosity, it is the mobile phase velocity, and in the y-axis, we plot the plate height. So and the resolution. Guys, do you know what is meant by resolution? What is meant by resolution? Do you guys know what is meant by resolution? Do anyone know about the resolution? So basically, resolution states that how two peaks are efficiently separated. Ability to yeah, state with you. So how two peaks are efficiently separated. So basically, this has a poor resolution and this has a good resolution because here the two peaks are efficiently separated from the each other. So basically, this is the formula for the resolution, and this is the further formula where here they have included the retention factor. So basically, column chromatography, as I mentioned earlier. So there are two terminologies which we have been encountered, will we get encountered in the column chromatography, which is the RF and RX. What is meant by the RF, guys? Can anyone say me what is meant by the RF? What is RF? Retention factor, great. So it is basically the ratio between the distance. Great, guys. So basically, let us consider this as a TLC plate. TLC is also known as thin layer chromatography. For example, in which we coat the stationary phase on the surface of the TLC. So we have coated the stationary phase on the surface of the TLC plate. So basically, here is the baseline and here is the end line. So basically, we spot the sample on the on the TLC plate. We base it upon the absorption efficiency. Yeah, distance. Good, Sneha. Distance traveled by solute by distance traveled by solvent. Great, guys. Great. And what is meant by Rx? Do you guys know what is meant by Rx? What is meant by Rx? So Rx is nothing but the distance traveled by the sample to the same grade. So basically, it is the distance traveled by the sample to the distance traveled by the standard. So here I have a question for you guys. Range. What is the answer to this question, guys? The RF ranges from great. So basically, the RF value ranges from the 0 to 1. It is not, it is never greater than 1. Great, guys, great. So, 1 minute, guys. So, before I just, so let me have a, so before starting to the HPLC and GC, I will try to complete the small chromatography. So let us have a first discussion to the size exclusion chromatography. So in size exclusion chromatography, basically the principle of separation is, guys, in size exclusion chromatography, molecular weight and molecular size. So basically here we use the, what are the different stationary phase used in the size exclusion chromatography, guys? What are the different dextrane, Cephar dex, polyacrylamide gel. So basically, these are the different types of the gels which are used in the separation. So based upon the gel filtration and gel permeation, polystyrene beads, great texture. So gel filtration and the gel permeation. So the stationary phases uses in the are the cross-linker carbohydrates, which are soft gel, which includes Cephar-dex, which is dextran, Cephar-dex-dextran, agarose, which is Cepharose, polyacrylamide gel, which is also known as biogel. And another one is the gel permeation. So gel permeation, the stationary phase usually is semi-rigid or rigid, which includes polystyrene, dextran, controlled porosity glass beads. Guys, what is the difference between the gel filtration, gel permeation? What is
In
the
gel,
main difference? Come on.
in
Your voice is breaking. You can also type if you are having the connectivity issues. What is difference between the gel filtration and gel permeation? The both principle remains the same based upon the size exclusion chromatography. But what is the main difference?
in gel filtration, mobile phase is buffer, and while in gel permeation, mobile phase is paired in CCl4 and tetrahydrofuran.
Yeah, great. So basically, in gel filtration chromatography, the mobile phase is polar in nature. And while coming to the gel permeation, the mobile phase is non-polar in nature. So this is the whole principle of the size exclusion chromatography based upon the size as I mentioned that the each and every particle has its own pore size, and based upon the size of the molecules, they can enter into the stationary phase or they can remain outside. Those which remain outside are eluted out first. So next is the let's talk about the thin layer chromatography. So basically, thin layer chromatography, we take a thin plate. So generally, this plate can be made up of the aluminum or glass, and on the surface of this plate, we coat the adsorbent material. The adsorbent material can be K-silver, aluminum dioxide, K-silver, magnesia, silica, etc. And then we spot the samples on the plate, and we dip this plate in a mobile phase. So basically, we dip this in a mobile phase. The mobile phase travels through the plate by capillary action, and based upon the absorption efficiency, different components operate on this plate. While what is the principle of the paper chromatography? Paper chromatography. What is the
Partition.
principle? Partition. Great, great. So partition. So the stationary phase is mobile. The stationary phase is polar in nature or non-polar in nature in paper chromatography. Polar.
Pole.
Great, guys. Polar. So basically, the paper which is used in the paper chromatography is generally alpha cellulose, made up of alpha cellulose, and the cellulose consists of the 6% moisture. And the thin layer chromatography can be applied to different principles also. So if this is used for the adsorbents, so guys, say me the examples of the different adsorbents.
Alumina, charcoal, diatomaceous earth, silica gel.
Silica gel, great. So silica is acidic, basic, or neutral in nature. What is the nature of the silica? Is it acidic? Great. It is acidic in nature. And it is polar or non-polar? Polar, polar. Great, guys. Great, great, great. So basically, silica is very highly polar in nature. In order to convert into the polar silica into non-polar silica, we do the one step, which is known as silylation. We do the step silylation, where the silica consists of the OH groups. So as we know that it is made up of Si, and it is OH group. So basically, by adding the silylating agents, we convert this polar silica into the non-polar, and this non-polar silica, it is then packed into the columns. So basically, whatever we see the HPLC column, which are C18 column, C8 column, basically it consists of the octadecynyl silica. So where we convert the polar silica into the non-polar silica by adding some of the non-polar silylating agents and decreases its polarity. So there are different silica gels. So what is meant by silica gel G? Silica gel G. What does the G indicates?
Gypsum.
Gypsum. What are the different names of the gypsums? It is also known as calcium sulfate, or it also known as plaster of Paris. So generally, and what is meant by the silica gel GF254? Silica gel 254, GF254. So gypsum and fluorescent material. The fluorescent material which is used, it is nothing but zinc silicate. Zinc silicate. And alumina. So alumina is also used as a same adsorbent in the column chromatography or in the TLC. So wait a minute, guys. So let me frame a question here. Can't able to find a place. Wait a minute. Let me rub this. So alumina contain which binder? Is it CaSO4, which is gypsum? B, it consists of starch as a binder. C, it consists of no binder. Or D, it consists of agar as a binder. Come on, guys, answer to this question. Which binder does the alumina contains? Which binder? Read the question correctly, then answer it, guys. Which binder is present in the alumina? Everyone
Agar.
must answer to. It's not agar. Basically, the alumina itself has a binding capacity. That's why no binder is used. The silica, due to lack of its binding capacity, we use the calcium sulfate, but alumina consists of no binder. So here you have to remember, guys. So as I mentioned earlier, the paper chromatography consists of bound water in the pores of the silica stationary phase. So basically, this is. So basically, in TLC, in order to identify the compounds which are present on the TLC spot, different methods have been used. So it can be of the derivatizing agents. So, so to determine, for example, to determine the acids, we have to spray the bromocresol green. So this table is very important, guys. The derivatizing agents which are used for the detection of the different types of compounds in the TLC is very important, and it's have been asked for many years. So, for example, for lipids, the bromothymol blue is used. For alkaloids, mercuric nitrate is used. For amines and the amino acids, hydrin. As you also know that the classical example or the identification test is hydrin. For the aldehydes or ketones, we use the 2,4-dinitrophenylhydrazine. For general sulfuric acid, which is also known as the sulfuric acid is also known as which agent, guys? There is a specific name, I think so, curing agent or something which is known as sulfuric acid. Iodine vapors are also used. So these are the different compounds, class of compounds which are used for the charring agent. So basically the charring agent. And you also know that the ascending, descending, 2D development, ascending development is nothing but the mobile phase is moved from the bottom to top. This is ascending. While coming to the descending, from the top to the bottom, the mobile phase moves. And another one is the radial development, where the mobile phase is kept on a cotton, and from the radial it moves. And another one is the 2D development, where you first we move in the ascending or descending, then you turn the plate into the 90 degree angle, and then you again move it. So while in the presence in the available or binders, so basically 1 minute, guys. In the available adsorbents, so the charcoal has the strongest adsorbent property. Then it comes the alumina. Then it comes the magnesium oxide and silicon dioxide. The sucrose has the weakest, and the charcoal alumina are the strongest adsorptions. Here you have to guys remember it. So now let us have some of the discussion towards the HPLC. I think screen is visible to everyone.
Yes, sir.
So basically, this is how an HPLC equipment look alike. So this is how basically HPLC equipment look alike. So basically, in the bottle cans, we fill the mobile phases, and through the pipes it enters into the HPLC column. So this is the basically how the HPLC look alike. So it consists of a pump It is the injector, column, detector, and the collector. So as I mentioned, these are the different basic terminologies which you have to remember, guys. The peak width, the peak height, etc. The baseline drift, baseline noise is nothing but generally baseline should be straight. But due to the some of the mistakes in the column or in the sample, there can be lead to baseline noise, which is undesirable. Another one is nothing but peak fronting and peak tailing. So basically, if the peak is symmetrical in nature, then it is known as Gaussian peak. It is basically known as Gaussian peak. So it is indicated by, so let me add. So it is known as Gaussian peak. So if the peak is asymmetrical in nature, then it can lead to two phenomena: peak fronting and peak tailing. In peak tailing, this portion of the peak increases, while in the peak fronting, this portion increases. Next, as I mentioned, that poor resolution indicates the improper separation. This is one analyte and this is one analyte. But there is no proper separation between these two peaks. And this is baseline drift. So baseline should be always in the straight line. If there is a movement away from the straight line, then it is known as baseline drift. So basically, which I have uh, explained earlier, this whole concept, the Gaussian peak, tailing, fronting. So basically, the bad peak shape occurs due to the presence of bad column, a dead volume in the column. If there is any void in the column overload, chemical tailing, etc. So these all terminologies have been treated, have been explained earlier, guys. The retention time, the mobile phase retention, the TR retention factor, the capacity factor, selectivity factor. As I mentioned, that the selectivity coefficient, it is nothing but the capacity factor ratio between the two components. So these all terminologies have been said, you guys. So this is basically the indicates a resolution of 1 indicates the proper resolution. 1.25 is like this. This is the baseline. So basically, generally, the values of the resolution greater than 1 are sufficient to achieve the qualitative and quantitative, and even the resolution of greater than 0.5 are also sufficient to determine the number of components present. So for the qualitative analysis, resolution up to zero point 0.5 is enough. For the quantitative analysis, generally it is greater than 1 desired. So this is the formula to calculate the number of plate numbers, which I also mentioned earlier. The plate number, the height of the theoretical plates, the number of plates as I mentioned, the Van Diemet curve also I mentioned, the longitudinal diffusion, column defects. So these eddy diffusion, as I see guys, here it is mentioned. The molecules, whenever passing through the stationary phase, follows the different path. So due to these different paths, it leads to the band broadening. So this is the occurs if there's a peak, if they all moves in a single and all. And there is also a magic triangle in the uh, magic triangle in the HPLC, which says that there should be a balance between the mobile phase speed, injection volume, and resolution. So basically, increasing the speed of the mobile phase leads to the worse the resolution, and decrease in the injection volume, which is nothing but the sample volume, increases the higher resolution. So basically, in very microliters, the sample is injected into the column. So injecting high volumes of the column into the HPLC column may leads to the block of the column, and it leads to the poor resolution or the poor separation. So with increasing the mobile phase flow speed, the broadening also increases. If the stationary phase consists of the porous particles, part of the sample molecules may diffuse into the pores and remains even further behind, while the main part of the sample band is traveling in the mobile phase. So another one important terminology is the increase in the temperature and the reduction in the viscosity of the mobile phase speed up the mass transfer process, thus causes a smaller impact on the mass transfer term. So basically, whatever the mobile phase which we have used should be of the low viscosity, and generally at the increased temperature, the HPLC is performed so that the mobility of the mobile phase to the column is not affected, and the optimizing mass transfer occurs. So basically the particle size and the sample size. So basically the here you can see that sample concentration. As the sample concentration is the minimum, there is a efficient peak separation, and as the sample concentration increases, the peak separation decreases. So now let us talk about the instrumentation. So basically, first one is the pumps. So in order to pump the mobile phase into the HPLC, different types of pumps are used, like reciprocating pumps, etc. So different number of types of pumps that can be provide the necessary pressure and the flow rates. So basically, in HPLC, some of the factors should be optimized, which includes the flow rate, the pressure inside the column, the type of the detector should be used, the composition of the mobile phase. So these are the critical process parameters which are must be optimized while coming to the HPLC. So basically, the pneumatic pump where the necessary was the high pressure was achieved by the pneumatic amplification. So whenever we desired the high pressure, the pneumatic pumps has been used. There also been using of the syringe pump, where which was the simply a large, strongly constructed syringe with a plunger that was driven by the motor. So these today the whatever the new HPLC system which are installed in the industries and the institution, all are come with the reciprocating pumps which are either fitted with the piston or with the diaphragm. So while coming to the pneumatic pump, so basic principle of the pneumatic pump. So let me explain you guys. So basically, the whole HPLC system is connected by the non-return valve. So what happens is that so whenever the air passes through this system, the air causes the push down of this piston. So due to the push down of this system, the water the piston exerts a force downwards by which the solvent which we have get from the reservoir passes from here to here. And again, due to presence of the non-wall, due to presence of the non-return wall, due to presence of the non-return wall, the mobile phase always moves in the unidirectional. The multidirectional flow of the mobile phase is avoided, by which there is a no opposite movement of the mobile phase, and the air comes outside from the air and it again goes up. So basically, this is how all the pneumatic pump works. Have you guys understand how the pneumatic pump works, or should I have to explain again? Air enters from the here this side, it creates a pressure, the piston moves downward. By the pressure created by the piston, the mobile phase moves from the reservoir to the sample wall. Is it clear?
Yes, sir.
So this is what is all. So pneumatic pump has a much larger flow capacity than the piston type pumps. Nowadays, these are mainly used for the column pumping, not used for the general analysis. So pneumatic pump can provide extremely high pressure and are inexpensive. As I mentioned here, the air enters first, applies a pressure to the upper piston, which is directly transmitted to the lower piston, and it is connected to a liquid chromatograph. And another, as I mentioned, that non-return valves. So basically, what happens is that the whole HPLC systems are connected by the non-return valves. The reservoir to the column to the detector. Every point of time, the whole HPLC is equipped with the non-return valves. So non-return valves are mainly used for the unidirectional flow. So what happens is that so whenever so here it consists of the metal balls which are made up of the PTFE or the metal. So whenever the mobile phase try to move, the balls get up and they allow the movement of the mobile phase. So whenever but the mobile phase when they try to come back, the balls get seated on their seat. So basically it consists of their seat. So the balls get seated on the seat, by which they prevents the multi-directional flow of the mobile phase. They only allows the unidirectional flow. So another one is the syringe pump. So basically in the syringe pump, uh, it consists of a mobile phase. The whole it consists of a piston, the fast reflex motor, and by the syringe pump is rarely used nowadays. The only the used are the reciprocating pumps and the pneumatic pumps. So which is nothing but the reciprocating pump. So basically it consists of the motor. This motor rotates, which pushes this, uh, which is nothing but the piston. Due to pushing of this piston, the mobile phase moves from the solvent reservoir to the column. So basically this rotates. Due to the rotation of this, it occurs. So I think so this is a systematic diagram, guys. I think you can be able to understand. Here, the pressure applied, the piston moves, then it flows from here to here, then here to here. So basically, this is twin system pump. So solvent programming. So basically, sometimes the solvent, all the three solvents moves through the mixing wall, where in computer we said that how much concentration of each solvent should be injected, then it connected to the pump and it enters the sample wall. Or it can be, this is the whole system of the low pressure solvent programmer, and another one is the high pressure solvent programmer, where the each solvent is connected to a pump, where it pumps directly into the blender. This is the high pressure, this is low pressure. In high pressure, each solvent passes through the pump, which mixing in the, it gets mixed, then it enters into the sample wall. Next, so HPLC injector. To the sample injector, which is present in the HPLC, is known as six-port Renaud valve, which is very important, guys. This injection is very important. It consists of the six-port Renaud valve, and basically it injects the sample in the unidirectional flow. So basically, this is it has the two positions, the load position and the inject position. So in load position, the mobile phase moves from the column, from the pump to the column, while the inject position, there is an interconnection of this valve, by which the pump, it creates a loop and the sample get enters into the column. So while, as I mentioned here, the column, generally the column dimensions are this. The particle size normally present in the particle size of the stationary phase is generally 5 micrometer. The pore size is the 300 Armstrong, and generally, as I mentioned, C18 column are used. C8 column are also used. So for the, depending upon the use, there are the different types of the columns are occur. So for the analytical purpose, semi-preparative and the preparative. So for the analytical purpose, the particle size is very lower, which is 3 to 5 micron. For the semi-preparative, the particle size is 10 micron. And for the preparative, it is basically 10 to 13 micron. So this is the basically, as I mentioned, the sample load is basically between the microgram to the milligram. So the HPLC column, basically, it is made up of the stainless steel tube, which is sealed with the fittings on the both sides. The steel fittings in the end fittings keep the packing material in the column. So basically, the packing material which is present in the column is fitted to the column walls by using the steel frits, which holds the stationary phase adhere to the column wall. So as I mentioned that the solvents which are used, so solvents. So the UV transmission and the refractive index are the important characteristics for the detection of the substances. When using the UV detector, the mobile phase should not have a absorption range in the sample molecules and must be transparent to the possible UV light, so that it do not get interfere with the UV absorption of the sample. And when using the refractive index detector, guys, what is the name of the another name of the refractive index detector? Do you guys know another name of the refractive index detector?
bulk property detector.
Great, great. And it is also universal detector. And it is also a universal detector. So basically, in a HPLC, the two types of detectors are used: bulk property detector and solute property detector. So the bulk property detector can able to differentiate between the mobile phase. So basically, the bulk property detector are the two types: the conductivity detector and the refractive index detector. So in bulk property detector, the difference in the physical properties between the mobile phase and the solute are measured. So another type of detector which is used are the solute property detector. The solute property detector basically only the physical property of the solute are only measured. The physical property of the mobile phase are not mentioned. And as I mentioned that the water, the mobile phase which is used for the HPLC should be less viscous, so that because increase in the viscosity of the mobile phase can leads to the increase in the back pressure, and also leads to breakdown of the pump. So the solvent must be inert. It should be not react with the sample mixture. So this is all about the. So these are the different types of detectors which are used, which includes the UV detector, which is of the fixed wavelength, variable wavelength. So another one is diode array. So as the detector which are used are the fluorescence detector, electric electrical conductivity detector, refractive index detector. So these are the important different types of detectors which are basically used in the HPLC. So I will not go in the details of this detector because the basic principles remains the same. But the refractive index detector is the most widely used. The sample preparation. Another most important consideration in the HPLC is the sample preparation. The sample which is prepared should be free from impurities. It should not have any kind of impurities, and it should be transparent in nature, so that uh, and it should be of less viscosity, and it must get dissolved in the mobile phase. So basically, the sample which is used for the HPLC, it is prepared by the liquid-liquid extraction method or solid phase extraction method. So basically, this is the basic method steps which are used in the method development. As I mentioned that every compound has a different retention time. So the conditions for the method development should be optimized for the each type of analyte. Mm, so I think so. Let us have some of the discussion regarding the. Let me. So 1 minute, guys. Hmm. So as I mentioned earlier, also uh, about the absorption chromatography, where I have mentioned that the absorption principle, the absorbance, different used, strong force, weak force. So weak generally sucrose and starch have the weak binding, weak absorption, while the aluminum and charcoal have the strong binding. So basically, the column chromatography has the principle of the adsorption, and the factors which appreciate the column efficiency are the different length of the column. The length to width ratio of the column is increased and the column efficiency increases because the number of theoretical plates in the column increases. Particle size. So generally, as the particle size decreased, the separation is improved. Packing of the column. So basically, the two type of packing of occurs in the column chromatography. One is the dry packing, and another one is the wet packing. So basically, in dry packing, what we do is the material is added in small amounts so as to give the maximum packing intensity. In wet packing, the material is made into slurry with the solvent and added to the column in portion. So basically, in the dry packing, we first add the stationary phase so that we can have the maximum packing of the stationary phase into the column. Then we add the mobile phase. While in coming to the wet packing, we first prepare a slurry. Guys, The slurry is made by the insoluble solid particles or the soluble solid particles? The slurry is made by the insoluble solid particles or the soluble solid particles? Great, great. So basically the slurry is whole made up of the insoluble solid particles. So as I mentioned here also, the partition, the ascending, the descending, the radial or disk chromatography. As I mentioned about the RF, the filter paper, which is basically the Wattman filter paper, which is mostly used in the paper chromatography, which is generally made up of the alpha cellulose, beta cellulose. Mobile phases are these. Next, mm, thin layer chromatography, as I mentioned, basic operation is nothing but methods to prepare the thin layers on the plate. Generally, the thickness, as I mentioned, that we take a plate. On the plate, the adsorbent or the stationary phase is coated. Then the choice of the adsorbent is important. Choice of the solvent, detecting agent, developing chamber, and different materials. So these are the different materials. Adsorbents generally used are the silica, alumina, silica, cellulose. Binding agent, calcium sulfate is mainly used for the silica gel. Solvents which are used are the petroleum ether, calcium, carbon tetrachloride, benzene, chloroform, diether. These are all the organic agents, and these are the generally derivatizing agents as I mentioned here. Another most important chromatography is the gas chromatography. The gas chromatography is suitable for the thermostable compounds or thermolabile. Answer, guys. The gas chromatography, thermo, are suitable for the thermostable or thermolabile. Thermostable, great, guys. So basically, here in gas chromatography, it is can be of the two types: gas solid chromatography and gas liquid chromatography. In gas solid chromatography, in both cases, the bubble phase remains the same gas, but in case of gas solid chromatography, the principle is the adsorption, while in liquid chromatography, the principle is the partition. So, so basically, these are the different. I think so. The most important for the gas chromatography is the length of the column. So basically, the length of the column in the gas chromatography is larger when compared to the HPLC. The column length can range from the meters. So it can range from the 50 to 100 meters, or it can range from the 1 to 3 meters. The carrier gas. So the carrier gas. So carrier gas is most widely used as the helium or the nitrogen. Which carrier gas is not used in GC? First one, nitrogen, helium, oxygen. Uh, Helium, oxygen, nitrogen. Mm, Another one is the hydrogen. Answer, guys. Which carrier gas is not used in the gas chromatography? Sometimes hydrogen is also used. Some in rare cases it is used, but mostly oxygen is never used. Oxygen is never used as a carrier gas. But most widely used is the helium and the nitrogen. So basically, the pressure inside the gas chromatography is ranges from the 40 to 80 psiz, and the temperature can go up to the 400 degrees Celsius. So basically, the main two types of columns are used in the gas chromatography. The first one is the Golay column or the capillary columns. So Golay columns or the capillary columns, and another one is the packed columns. So in packed columns, the total stationary phase is packed within the column, and through the stationary phase, the gas gets passed. So these are the uh, packed column, and the capillary column can be of the ball coated open tubular column or surface support coated open. forgot. So let me write here, guys. So the capillary column can be of WOCT, BCOT, or SCOT. So ball coated open tubular column is nothing but the wall of the gas column consists of a stationary phase in the form of liquid. In the form of liquid is coated. While coming to the surface or the support coated open tubular column, so basically the stationary phase is coated on the supporting particles. The supporting particles are coated on the column and the mobile phase is present on the surface of this column, on the surface of this particle. Cantilever, Teflon, etc. And the column can be U-shaped, coiled, or straight. So as I mentioned that solid inert support, the main purpose of this to provide support to the film, the thin uniform film of the liquid phase, basically which is cantilever diatomaceous earth. And as I mentioned that a liquid, so the liquid which is generally coated is the ethylene glycol or the silicon polymers. So the stationary phase liquid phase can be squalene or the polar liquids like polyethylene glycols. So most important type for the most important thing while coming to the gas chromatography is the detectors. So first one is the thermal conductivity detector. What is the other name of the thermal conductivity detector?
Catharometer.
Catharometer. Another, there are two, there are one, two, three, four names for the thermal conductivity detector.
Hot wire detector.
Great. Next, it is also a universal detector. So basically, it is the concentration type detector, and it consists of the support gas. Which what is the support gas? What is the carrier gas for the thermal conductivity detector? So basically helium. So while coming to the helium, great guys. Flame ionization detector. So flame ionization detector is a mass flow type detector, and it is sensitive to the organic compounds and the water. Another one type detector is the electron capture detector, ECD. It is used for the detection of the halides, nitrates, nitrites, halogens, peroxides, etc. So another detector which is not mentioned here, I think so, it is thermoionic specific detector, which is also known as, guys, what is the another name of this detector? NP detector. It is NP detector. So NP detector. So basically it consists of the electrical heated bead of solid alkali metal compound, rubidium silicate. So basically it consists of a solid alkali compound which is made up of rubidium silicate, and it is used for the detection of, do you guys know which compounds are detected by this detector?
Nitrogen and phosphorus.
Great. Nitrogen, phosphorus. Great. Next detector is the flame photometric detector. Flame photometric detector, and it is used for the detection of
Sulfur and phosphorus.
sulfur. Yeah, great guys. Sulfur, phosphorus, tin, boron, arsenic, selenium, etc. Next one is the photoionization detector, and it is used for the detection of Come on, guys, answer. The photoionization detector is used for the detection of basically the aliphatic compounds, aromatics, ketone, amines, esters, aldehydes, etc. These are all of the compounds which are detected by the heterocyclic. Great, guys. Great, great. So flame ionization detector is the most commonly used in the gas chromatography. So flame ionization detector is used to the detecting of the all organic compound except the formic acid. You have to remember it, guys. The flame ionization detector shows the greater response to the hydrocarbons, and the electro capture detector (ECD) detector is only detector which is so sample derivatization. So basically, sometimes in the gas chromatography, we do the derivatization because in order to detect by the sample by the gas chromatography, it must not get decomposed and it must not be non-volatile in nature. So in order to main convert the compound into the heat stable and non-volatile in nature, we generally derivatize this compound. So basically derivatizing the compound by using the silylating agents. Silylating agents are used to derivatize this compound. Do you guys anyone remember the name of any silylating agent? Do anyone know the silylating agent examples? Any one example you guys can able to say me? Any one example of the and trimethyl silane imidazole, NO, bis trimethyl silane trifluoro acetamide. Another one is same the same bis trimethyl trifluoroacetamide, but here you remove the trifluoro. The another example is the same. So these are the different silylating agents which are reacted with our sample to make our sample. The temperature maintained in the gas chromatography can sometimes go up to 400 degrees Celsius. So basically, for the quantitative analysis, so basically qualitative analysis is basically done by detecting the peak, while the quantitative analysis is done by the measuring the peak height and the peak width. So basically, in the stationary phase, as I mentioned that in the size exclusion chromatography, it is generally the styrene divinyl benzene copolymer or the cross-linked dextran. So which chromatography is used for the separation of protein, guys? Proteins are separated by which chromatography? Mainly proteins, peptides. Guys, great, guys, great. So another one is the chiral chromatography. In chiral chromatography, either the mobile phase or the column is chiral, and it is used to separate the enantiomers. Column derivatization. So this is the basically the normal phase and reverse phase. So this is basically C18 column where the OH group of this silicon are reacted with the octadecynyl silane, and these are converted into the hydrophobic in nature. This hydrophobic silica is then coated in the HPLC column wall. That's why the column is also known as C18 columns. So basically, sometimes the end capping phenomenon is also done because the C8. So basically, for example, What is end capping? I will explain you guys. Do you guys know the phenomena of the end capping? Do you guys know the phenomena of the end capping? Do anyone know the phenomena of the end capping? So what basically happens in the end capping is, for example, I have chosen a octadecynyl silane. So for example, it is a long carbon chain which is bound to the one OH group in place of one OH group. And this is the another one big chain. So what happens is the the OH group sometimes some of the OH groups are not getting silylated or not getting derivatized due to the repulsion and the another big chain between these two chains due to this large bulky chain. So in order to by which it can lead to some of the partial polarity in the silica. So in order to remove that partial polarity, we use the smaller silylating agents by which they can able to uh, silylate this group which is present between the two larger chains. So this is known as end capping. So another important chromatography is the affinity chromatography, which is also known as based upon the chromatography lock and key mechanism in which the enzyme reacts with the substrate. So basically what we do is, for example, I have a sample which consists of these mixture of different enzymes, but I want to only separate only one type of enzyme. So what will I do? Affinity for this specific substrate. So that substrate I will quote on this column. I will quote on this column. Then I will add the sample in a buffer and I will pass through this column. So the enzyme which is having the affinity for this substrate will bind to the substrate. And while the other enzymes will get eluted out from the column. Now, by changing the pH of the solution or the ionic strength of the solution, I will break this enzyme substrate bond by which now I can collect the pure form of the enzyme. So this is how the affinity chromatography works. This same works for the antigen antibody, proteins, and etc. So another most important type of chromatography is the ion exchange chromatography. So what is meant by ion exchange chromatography? So basically column with the ion exchange resins. So it can be anionic resin or cationic resin. So basically, there are the sample consists of the anions or cations. So cations can be Na plus or it can consist of the anions like Cl minus. Here we coat the stationary phase with a resin. So resin, for example, if it is cationic in nature, cationic resin means the resins are attached to the positive cations and the resins must be negative in nature or positive in nature, guys. In cationic resin, the mobile ions are positive in nature. Then the resin is negative in nature or positive in nature. No, no, Vivek, it's not positive. In cationic resin, the resin is negative in nature, while the mobile ions are positive in nature. The resin is negative in nature. Now we fill or we put the stationary phase in the column and we pass our sample. So whatever the sample consists of the positive ion samples will be displaced by these mobile ions and by which the all samples containing the positive ions will bound to this cationic exchange resins. Then we will pass the buffer and we will separate this sample ions. So this is basically how the separation occurs. So these are the different types of resins which are coated. So strongly acidic cationic exchange resins. Example includes sulfonated polystyrene resins. Weakly acidic cationic exchange resins includes carboxylic polymethyl acrylic ammonium polystyrene resins. weakly basic anionic resin cycles, phenol formaldehyde and polyamide increases. So is any doubts up to now, guys? Does anyone has any doubt up to now regarding the whole chromatography? I have given the whole revision of the chromatography, and I hope everyone has been clear with the chromatographic concepts. Still, anyone has any doubts related to the chromatography? Any
Sir,
doubts?
sir, temperature programming technique, gas chromatography.
Okay.
Only
So
synthesis.
basically, what we have is, so basically in gas chromatography, we have a column, we have a sample point, we have a detector. So there is a two temperature programming in the gas chromatography. One is the isocratic, basically the isocratic. So in which the sample point, the column, and the detector are maintained at the same temperature. But while in the temperature programming, which is the nowadays most widely used in the gas chromatography, here is the we specifically first maintain a particular sample, this particular temperature at the sample point. Then while coming to the column, we maintain the another temperature. And then while coming to the detector, we maintain the another temperature. So by which we can able to modulate the temperature throughout the separation, by which we can prevent the decomposition of our sample, because the sample in the gas chromatography is always in the vapor phase. It is not in solid or liquid phase. So by modulating the temperature throughout the chromatographic column, the sample and also prevents the decomposition of the sample. I think it is clear. Basically, it is same like the gradient dilution where you program the polarity of the solvent, while in the temperature programming, you program the temperature. Is it clear?
Yes, sir.
Still any doubts? Anyone has any doubts regarding chromatography? Anyone has any doubts? Any other doubts? I think so. No one has any doubts today, guys. So I will gonna share the some of the MCQ related to the chromatography and the analysis to the team, where you can solve those uh, basically all those MCQs and revise it. So basically, you guys have only left with the hardly 1 month, I think so. Today the date is 4th, and you are having exam on the 8th, I think. On the 8th, I think you guys are having exam.
Yes, sir.
Uh, so basically, I would suggest that everyone, you guys go through these all classes which are have been taught by the every educated. See at 1.5x or 2x, revise the classes, try to solve the maximum amount of MCQs that you can solve, try to clear your concepts. Now this time you don't try to read any new things, try to revise your old in the final examination. So that's it for today, guys. If you can have any doubts, you can reach out to the team where we can clear your doubts, guys. Thank you everyone for